Right now, as you are watching this, the ground beneath the state of Georgia just did something that, according to every geology textbook published in the last century, it is not supposed to do. On July 17, 2026, at 5:43 in the afternoon Eastern Time, seismographs across the southeastern United States picked up a magnitude 2.4 earthquake. The epicenter sat roughly 204 kilometers north of Atlanta, buried 17 kilometers deep inside rock that is over 1 billion years old. That same month, a magnitude 2.1 tremor had already rattled the town of Trenton in Dade County, at the extreme northwest tip of Georgia where three states converge. And just 4 months before that, a 2.1 struck near Varnell in Dalton and Whitfield County, deep inside a zone that the United States Geological Survey has been quietly monitoring for decades. 3 earthquakes, 1 state, a matter of months. That might sound routine if we were talking about California, but we are not talking about California. We are talking about Georgia, a state that sits more than 3,200 kilometers from the nearest active plate boundary. A state where 15% of the world's earthquakes happen in places exactly like this, places that lack any clearly defined active faults, places where the textbook says the ground should be permanently quiet. But the ground is not quiet, and what scientists are now finding buried beneath the rolling hills of Appalachia is fundamentally changing how we think about earthquake risk in America. Today we are going to break down exactly what is happening underneath Georgia, why the science says these earthquakes should not be possible, and whether the real danger in the southeast is much closer than anyone has been willing to say out loud. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever felt an earthquake in a place where you were told they simply do not happen? Tell me where you were and what it felt like. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Now let us get into it. The earthquake on July 17th arrived without any warning. At 1743 Universal Coordinated Time, instruments registered the rupture at a depth of 17 kilometers beneath the surface. 17 kilometers. To put that in context, the deepest point in the ocean, the bottom of the Mariana Trench, is only about 11 kilometers below sea level. This earthquake originated deeper than that, entombed inside the Precambrian basement rock, the ancient crystalline foundation of the North American continent. This is rock that predates complex life on Earth, rock that was formed when the planet's surface looked nothing like it does today, and it just moved. The epicenter was plotted to a point roughly 204 kilometers north of downtown Atlanta, placing it inside the same geological corridor that has been generating small but persistent tremors for years. No injuries were reported, no buildings were damaged. Most people in the area probably did not even know it happened, but the instruments knew. Rewind to March 17th, 2026. A magnitude 2.1 earthquake struck near Varnell in Whitfield County, northwest Georgia, at 2:35 in the afternoon local time. The USGS confirmed it originated at a depth of roughly 13 kilometers, about 8 miles, placing it squarely inside the Eastern Tennessee Seismic Zone. Residents in Varnell, Tunnel Hill, Catoosa Springs, and Ringgold may have felt a slight nudge, a rumble, a vibration that lasted a few seconds and then vanished. The Dalton area sits right at the foot of the Appalachian foothills, carpet mill country, small towns with brick downtowns and churches built in the 1950s. None of those buildings were designed with earthquakes in mind. None of them. Then on June 17th, another 2.1 hit Trenton, in Dade County, at the extreme northwest tip of the state, right where Georgia, Alabama, and Tennessee converge. The depth was recorded at 0 kilometers, meaning the rupture was so shallow that the monitoring network could not resolve its exact position. Again, no damage. Again, no injuries. Again, a data point that most people will never know about. 3 events in 4 months, each one small, each one essentially harmless on its own, and each one a signal in a pattern that has been building for longer than most Georgians have any idea. To put Georgia's seismic situation in the proper context, you need to understand what it means to live in the middle of a tectonic plate. The outer shell of the Earth is broken into roughly 15 major tectonic plates. These plates float on the semi-molten rock of the asthenosphere beneath them, moving anywhere from 1 to 15 centimeters per year. Where plates collide, you get mountain ranges. Where they pull apart, you get rift valleys and mid-ocean ridges. Where they grind past each other sideways, you get transform faults. And along every one of these boundaries, you get earthquakes. Constant, powerful, well-understood earthquakes. That is the engine. The North American plate is enormous. It stretches from the mid-Atlantic ridge in the center of the Atlantic Ocean all the way across to the western coast of the continent. California sits right on the transform boundary where the Pacific plate slides northwest past the North American plate along the San Andreas Fault. That boundary is roughly 1,200 kilometers long. It generates thousands of earthquakes every year. It has produced magnitude 7 and magnitude 8 events within recorded history. Everybody in California knows they live in earthquake country. The infrastructure reflects it. The building codes demand it. The culture acknowledges it. Georgia sits over 3,200 kilometers from that boundary. Over 3,200 kilometers from the nearest subduction zone. Over 3,200 kilometers from the nearest divergent rift. By every classical model of plate tectonics, the crust beneath Atlanta, Macon, Savannah, Augusta, and Dalton should be among the most geologically stable, geologically quiet, geologically boring real estate on the face of the Earth. No active subduction, no transform boundary, no continental rift pulling the land apart. The nearest plate edge might as well be on another continent. The traditional model says the earthquakes should not be here. But here is the thing nobody expected. The earthquakes keep coming anyway, and they have been coming for as long as anyone has been measuring. The Eastern Tennessee Seismic Zone is the second most seismically active region in all of North America east of the Rocky Mountains. It trails only the New Madrid Seismic Zone in western Tennessee and southeastern Missouri. The ETSZ runs on a northeast-southwest trend from northeastern Alabama through northwest Georgia straight across Tennessee and into southeastern Kentucky. It stretches roughly 300 kilometers end to end. Seismicity within it clusters between 5 and 26 kilometers deep, all of it inside the Precambrian basement rock beneath the Appalachian sedimentary cover. The largest recorded earthquake in the zone's instrumented history measured magnitude 4.8. Most events are magnitude 1 or 2, too small for any person to feel, but the instruments feel them, and they record them, and the catalog grows. But here's the part that should genuinely concern every person living in the Southeast. Researchers at Georgia Tech, the USGS, and multiple university seismology programs have found paleoseismic evidence, physical scars preserved in rock and soil, suggesting that the Eastern Tennessee Seismic Zone is capable of producing magnitude 7 or larger earthquakes. That evidence comes from detailed trenching studies along what researchers call the Dandridge-Vonore Fault Zone in eastern Tennessee. In those trenches, scientists found displaced alluvium, river sediments that had been physically cut and shifted by 1 to 2 meters by faulting events that occurred sometime after 25,000 years ago. That means within the geologically recent past, well within the span of human existence on this planet, something enormous happened along this corridor. Something orders of magnitude larger than a 2.1 near Varnell. If you follow earthquake science at all, the phrase intraplate earthquake probably already rings a bell. Every earthquake in Georgia, every earthquake in Tennessee, every earthquake in South Carolina and Alabama and Virginia, these are all intraplate earthquakes. They happen not at the edges of tectonic plates, but deep within the interior. And they account for roughly 5% of all earthquakes worldwide. 5% might sound small. It is not. That 5% includes some of the most destructive earthquakes in American history. The explanation goes back hundreds of millions of years. The eastern edge of what is now North America was once a violently active plate boundary. Continents collided, oceans closed, mountain ranges rose to heights that rivaled the modern Himalayas. The Appalachian Mountains that you see today as gentle, rounded, tree-covered ridges were once among the tallest and most jagged peaks on the planet. And when those mountains formed, the collisions did not just push rock upward. They fractured the crust at enormous depths, creating fault systems that were eventually buried under hundreds of millions of years of sediment, erosion, and geological quiet. Those faults never healed. Rock does not heal. The fractures are still down there, exactly where they were left, sealed under billions of tons of overlying material but structurally weakened compared to the intact crust around them. And every now and then, when the slow, relentless pressure from the mid-Atlantic ridge pushes the North American plate westward, or when glacial isostatic rebound continues to adjust the crust from the removal of ice sheets that covered the northern part of the continent more than 10,000 years ago, or when deep crustal fluid pressures shift for reasons scientists are still working to understand, those ancient faults slip. Just a little, just enough to send a pulse of energy to the surface. Just enough to register on a seismograph. And occasionally, just enough to rattle the dishes off a shelf. But here's the problem that makes the Southeast uniquely dangerous. When an earthquake releases energy in the eastern United States, that energy travels dramatically farther than an equivalent earthquake in the western United States. The bedrock beneath the eastern seaboard is older, colder, drier, and far less fractured than the younger, hotter, more broken-up rock beneath California and the Pacific Northwest. Old, cold rock transmits seismic waves with ruthless efficiency. A magnitude 5.5 earthquake in the southeast can typically be felt as far as 480 kilometers from its epicenter, and it can cause damage up to 40 kilometers away. That same magnitude 5.5 in California would be felt over roughly 1/3 of that distance. Same energy, same magnitude number on the scale. 3 times the reach. That changed fast on May 10, 2025. At 9 o'clock in the morning Eastern Time, a magnitude 4.1 earthquake struck near Greenback, Tennessee, roughly 48 kilometers south of Knoxville. The rupture occurred about 24 kilometers below the surface. Within the first 60 minutes, the USGS received over 29,000 "Did you feel it?" reports from the public. By the time the reporting closed, more than 45,000 individual reports had been filed. People felt the shaking in Chattanooga, Tennessee, in Atlanta, Georgia, in Asheville, North Carolina, in Greenville, South Carolina. One earthquake, magnitude 4.1, felt across 4 states and hundreds of kilometers of distance. That is what old, cold, efficient bedrock does. It turns a moderate earthquake into a multi-state event. The Greenback quake was the second strongest felt in the Eastern Tennessee Seismic Zone in 25 years. The strongest in recent memory was a 4.4 near Decatur, Tennessee in December 2018. That one struck at 4:14 in the morning and shook homes as far away as downtown Atlanta. Engineers were immediately dispatched to inspect the Watts Bar nuclear plant on the Tennessee River as a precautionary measure. The Tennessee Valley Authority confirmed the plant was not affected and continued to operate safely. But a 13-minute aftershock of magnitude 3.3 followed, and for the residents of Eastern Tennessee, sleep was over for the night. The difference between Georgia and California is not luck, it is not randomness, it is geology. And geology, in this particular case, makes the Southeast more vulnerable to damage per unit of earthquake energy than almost anywhere else in the continental United States. Keep an eye on this number too. Georgia has averaged roughly 26.7 earthquakes per year over the past 56 years. The vast majority are magnitude 1 and 2 events that only instruments detect. But approximately every 15 to 20 years, based on the historical record, a magnitude 4 or above strikes somewhere in or near Georgia. The strongest earthquake recorded near Georgia since 1900 measured magnitude 4.4 and struck on December 12, 2018. Before that, the record stretches back to a 4.7 in 1973. Before that, you run out of instruments. The seismograph network in the Southeast simply did not exist in the 1800s, which means we have no instrumental record of whatever shook Georgia before the 20th century. And the geological record says things much larger than a 4.4 have happened here. But the most terrifying precedent for the Southeast did not happen in Georgia at all. It happened next door. And it happened before anyone alive today was born. On the evening of August 31st, 1886, at 9:51 p.m. local time, a massive earthquake struck Charleston, South Carolina. Modern estimates place the magnitude somewhere between 6.9 and 7.3. The shaking lasted less than 1 minute. In that 1 minute, over 2,000 buildings were damaged or destroyed. The official death toll was recorded as 60, but subsequent historical research has pushed that number to at least 124 confirmed dead and 139 severely injured. Some victims died not from the shaking itself, but from fever and exposure in the days and weeks afterward, because so many people were living in the streets and parks, terrified to go back inside any building. Property damage was estimated at $5 to $6 million in 1886 money. Adjusted to today's dollars, that is roughly $192 million. Structural damage was documented in central Alabama, central Ohio, eastern Kentucky, southern Virginia, and western West Virginia. Railroad tracks were twisted and displaced. A locomotive was derailed and damaged. The city of Charleston was effectively cut off from the outside world. The earthquake was felt in 27 states and the District of Columbia. It was felt in Boston, in Milwaukee, in Chicago, in Cuba, in Bermuda, and major damage reached as far as Tybee Island, Georgia, more than 96 kilometers from the epicenter. For 30 years afterward, more than 400 aftershocks continued to rattle the Charleston area, some of them occurring every 16 hours. The 1886 Charleston earthquake was classified as an intraplate earthquake. Scientists believe it occurred on ancient faults formed during the breakup of the supercontinent Pangaea. The exact fault that ruptured has never been conclusively identified. That means scientists still do not know precisely which fracture produced one of the most devastating earthquakes in American history. And here's what the USGS says would happen if the exact same earthquake struck the exact same location today. With the population growth, the urban development, the high-rise construction, and the infrastructure expansion that Charleston has experienced over the past 139 years, modeling studies have determined there could be 900 deaths and billions of dollars in damage. That is not a California earthquake. That is not a subduction zone event. That is not a transform fault rupture along a well-mapped plate boundary. That is the middle of a tectonic plate. The exact kind of place where 3 generations of geologists were taught that major earthquakes simply do not happen. These are not just geological events, they are human experiences, and the Southeast is uniquely unprepared for them. According to Georgia's own Emergency Management and Homeland Security Agency, houses in the Southeast are built to stand upright but may not withstand shaking. That is a direct statement from the state's official preparedness website. Chimneys, roof structures, and unreinforced brick facades are standard construction practice across Georgia, South Carolina, Tennessee, and Alabama. These are exactly the structural elements that fail first in an earthquake, Falling bricks from chimneys and wall facings, if not properly secured, can cause significant damage or injury. That is not my assessment. That is what the state of Georgia tells its own residents. Georgia identifies its highest risk counties in 3 distinct clusters. The first is the Northwest Corridor, including Bartow, Catoosa, Chattooga, Dade, Faunin, Floyd, Gilmer, Gordon, Murray, Pickens, Walker, and Whitfield counties. These sit directly inside or adjacent to the Eastern Tennessee Seismic Zone. Every one of the 2026 earthquakes I described earlier fell within this cluster. The second cluster runs along the South Carolina border, including Rabun, Towns, and Union counties, tapping into the same ancient Appalachian fault systems. The third sits in central and west-central Georgia, including Twiggs, Bibb, Jones, Baldwin, Hancock, Greene, Putnam, Butts, Jasper, Newton, Morgan, Walton, Harris, and Muskogee counties, an area that most Georgians would never associate with earthquake risk. Meanwhile, a research team at Georgia Tech's School of Earth and Atmospheric Sciences has been working with matched filter detection methods to build a more complete earthquake catalog for the entire southeastern United States. The problem with traditional seismograph networks is that they miss smaller earthquakes, events that are buried in background noise or hidden in the coda waves of larger events. The matched filter technique uses the recorded waveforms of known, confirmed earthquakes as templates and cross-correlates them against continuous seismic data streams to find previously uncatalogued events. In plain English, they are using known earthquakes as fingerprints to search for hidden earthquakes in old data that nobody knew were there. And what they are finding is that the official earthquake counts for Georgia and the Carolinas significantly understate how seismically active these zones truly are. There are far more small earthquakes happening beneath the southeast than the standard catalog shows. The earth is busier down there than anyone realized. And here's where it gets personal for anyone living in the southeast right now. The New Madrid Seismic Zone, sitting in western Tennessee and southeastern Missouri, produced 3 of the largest earthquakes in the entire recorded history of the United States. Between December 1811 and February 1812, 3 magnitude 7 earthquakes struck in rapid succession along the Mississippi River. The shaking was so severe that it knocked down trees across thousands of square kilometers. It caused the Mississippi River to flow backward temporarily, filling newly created depressions in the landscape. It created an entirely new lake, Reelfoot Lake in western Tennessee, which exists to this day as a direct result of earthquake-induced ground subsidence. Church bells rang in Boston from the shaking, structural cracks appeared in buildings in Washington, D.C., the earthquakes were felt across the entire eastern half of the continent. The New Madrid events proved beyond any doubt that the interior of the North American plate can produce catastrophic earthquakes. And here is the uncomfortable connection. The same fundamental mechanism that drives the New Madrid seismic zone, ancient faults reactivated by modern stress fields in the deep crust, is the same mechanism that drives the Eastern Tennessee Seismic Zone, the same mechanism that puts earthquakes underneath Georgia. The geology is different in its details, the fault orientations and depths vary, but the principle is identical. Old fractures, modern stress, eventual slip. The 1811 and 1812 New Madrid earthquakes happened when the central Mississippi Valley had a population of a few thousand people scattered across remote frontier settlements. If those same earthquakes struck today, with Memphis, Nashville, St. Louis, and Louisville all sitting within the damage zone, the USGS estimates the losses could exceed $300 billion and affect more than 7 million people directly. Now bring that same lens back to Georgia. Atlanta is the economic capital of the Southeast. Metro Atlanta has a population exceeding 6 million people. The city's infrastructure includes a major international airport, one of the busiest in the world, an extensive highway system built on elevated overpasses, a rapid transit rail network, and thousands of high-rise buildings, many of which were constructed before modern seismic design provisions were incorporated into Georgia's building codes. Very few homeowners in Georgia carry earthquake insurance. Very few residents have ever practiced an earthquake drill. Very few buildings outside of the newest commercial construction have been evaluated for seismic resilience. Consider this. A study referenced by Georgia's Emergency Management Agency found that 15% of all earthquakes worldwide occur in areas like Georgia, areas that have no clearly defined active faults. That means 1 in every 6 or 7 earthquakes on the planet happens in a place that looks, on the surface, exactly like the suburbs of Atlanta, exactly like the mill towns of northwest Georgia, exactly like the quiet college towns of central Georgia. And the buildings in those places are not ready. The chimneys are not braced. The brick facades are not reinforced. The water lines are not flexible enough to survive ground displacement. The emergency plans, if they exist at all, focus on tornadoes and hurricanes. Earthquakes are an afterthought. In many communities, earthquakes are not even on the list. That is the gap, not the earthquake itself, the gap between the real risk and the perceived risk. Californians know they live in earthquake country. They prepare accordingly. Georgians, by and large, do not believe earthquakes are part of their reality. But the seismographs say otherwise. The trenching studies say otherwise. The 124 people who died in Charleston in 1886 say otherwise. The question that keeps seismologists awake at night is not whether the Southeast will experience another significant earthquake. That question was answered a long time ago. The answer is yes. The real question is when, and how large, and whether the millions of people living on top of these ancient, unmapped, poorly understood fault systems will have any idea what to do when it happens. The honest answer from the current state of the science is that seismologists cannot accurately predict when or where the next major intraplate earthquake will strike the Southeast. The recurrence intervals between large events can span hundreds or even thousands of years, which makes short-term forecasting essentially impossible with today's tools. The driving mechanisms themselves are still actively debated in the scientific literature. Some researchers point to far-field stress transmitted across the entire plate from the mid-Atlantic ridge. Others emphasize glacial isostatic adjustment, the continuing slow rebound of the crust after the enormous weight of Ice Age glaciers was removed from the northern part of the continent more than 10,000 years ago. Still others argue that localized thermal anomalies in the upper mantle, or changes in fluid pressure deep within the crust, may play a role in reactivating ancient faults. What is not debated is this. The faults are real. They have been mapped. The earthquakes are real. They have been recorded. The historical precedent is real. Charleston proved it. The vulnerability of millions of homes and buildings across the Southeast is measurable, documented, and acknowledged by the state agencies responsible for emergency preparedness. Georgia is not California. Nobody is saying it is, but the assumption that Georgia is permanently safe from earthquakes, that the ground beneath Atlanta, Dalton, Savannah, and Macon is and will always remain quiet. That assumption is not supported by the evidence. The evidence says the opposite. The evidence says these ancient faults are not extinct. They are dormant, and in geology, dormant is not the same thing as dead. Dormant means waiting. Dormant means the pressure is still building. Dormant means the fault is there, and it remembers what it was built to do. The most realistic danger for 10 million Georgians is not hiding in some deep subduction trench thousands of miles away. It is not lurking along a famous fault line in California that gets all the headlines. It is sitting quietly just a few feet beneath the ground that people are standing on right now. Ancient fractures in billion-year-old rock, buildings that were never designed to shake, and a population that has largely been told there is nothing to worry about. If this was useful, hit the like button. We are still pushing for 5,000 on this one, so the algorithm shows this to people who actually need to hear it. And if you have ever felt an earthquake anywhere in the Southeast, in Georgia, Tennessee, the Carolinas, Alabama, anywhere you were told the ground does not move, drop a comment and tell me exactly what it felt like. I read every single one. See you in the next one.